Good afternoon, everyone. I'm Aravind, a technical trainee at Wings of Aero. It's a glorious moment to extend my warm wishes on behalf of the Wings of Aero. I would like to explain about the TEMS Era platform and our previous chief guest. TEMS is India's digital learning platform that provides advanced learning and research opportunities for science and engineering students. These are our previous courses. Dr. Dharmahinder Singh Chand, Professor and Head Aerospace Engineer, Chandigarh University. He was delivered his session Gas Turbine and Space Propulsion on our platform. Professor Jayan Murthy, Indian Institute of Astrophysics. He was delivered his session Robotics for Future Space Astronomy on our platform. Professor Prasanna Ramamurthy, Collins Aerospace Principal System Engineer. He was delivered his session on avionics architecture and data bus on our platform. Today, our chief guest, Dr. N. Thangaraj. First of all, I want to convey my heartfelt gratitude to Dr. N. Thangaraj, Professor of Physics, Velalar College of Engineering and Technology, for accepting the invitation and presiding over the seminar on nanotechnology in satellite communication. The webinar was conducted and organized by Wings of Aero for the science and engineering students to gain insight and information that would remain effective in their research and project. Thank you. Sir, you will take the session.
Okay, sir. Thank you. Welcome to another episode. I'm Dr. N. Thangaraj, Professor of Physics, Velalar College of Engineering and Technology, Year 12. I'm going to discuss about nanotechnology in satellite communication. And what are nanomaterials? So we don't know that 10 power minus 9 meters are nanomaterials. The nanoscale materials are defined as a set of substances where at least one dimension is less than approximately 100 nanometers. A nanometer is 1 millionth of a millimeter, approximately 1 lakh times smaller than the diameter of a human hand.
Sir, sorry
Okay.
for the disturbance, sir.
Hmm.
Sir, it's not audible, sir. It's like a noise and echo, sir. It's make echo.
Cool. Hello.
Sir,
Is it audible?
echo audible, sir, but echo இருக்கு, sir.
Hello. Is it okay, sir?
Yes, sir, audible,
The thing is not okay.
but echo, lightly echo இருக்கு, sir.
Hello.
Hello, sir.
Is it audible, sir?
Yes, audible, sir.
Still, is there any echo?
Okay, sir. You can continue, sir.
Okay. Nanomaterials. Actually, all of you know very well about the nanomaterials. Nano means 10 power minus 9 meter. Nanoscale materials are defined as a set of substances where at least one dimension is less than approximately 100 nanometers. A nanometer is 1 millionth of a millimeter, approximately 1 lakh times smaller than the diameter of a human hand. Okay, what's mean by nanotechnology? First of all, you see that nanoscience. Nanoscience deals with synthesis of nanomaterials and study the characteristics. Here, the nanotechnology using the nanoscience and making the new device is used for our day-to-day purpose. Okay. Nanotechnology is a branch of engineering that deals with the design and manufacture of extremely small electronic circuits and mechanical devices built at the molecular level of a matter. Okay, why is this nano? What are the interest of nanomaterials? Nanostructure semiconductors have various non-linear optical properties. It's a very, very important one, non-linear optical properties. Nano-sized metallic powders used for the production of gas-type materials, dense parts, and porous coatings. Nanostructured metal clusters and colloids of mono or plurimetallic composition have a special impact in catalytic applications. Nano-based ceramics are more ductile at elevated temperatures. Nanostructured metal oxide thin films are used in gas sensors due to enhanced sensitivity and selectivity. Polymer-based composites with a high content of inorganic particles leading to a high dielectric constant. Synthesis. What are the methods used to produce nanomaterials? There are two processes in this synthesis. One is top-down and one is bottom-up approach. In this top-down, bulk materials are broken into...
Sir, 1 minute, sir. Sir, 1 minute. Sir, sorry. Sir, just அது எங்களுக்கு எக்கோ வந்து உங்க ஹெட்செட் தான் ப்ராப்ளம் நினைக்கிறேன் சார். அது ஹெட்செட் ரிமூவ் பண்ணிட்டு மைக்ல பேசி பாக்குறீங்களா சார்? ஸ்டூடெண்ட்ஸ்க்கு வந்து கிளியர்னஸ் இல்லை சார் யூடியூப்ல ஸ்ட்ரீம் ஆகுறது, அதுக்கு தப்பா எடுத்துக்கிறீங்க சார். வாய்ஸ் இருக்கா, நான் பட் வேர்ட்ஸ் கிளியாரிட்டி இல்லை சார்.
Is it okay?
சார் பேசுங்க.
Is it okay, sir?
ஓகேவா சார்? சார் ஓகே சார்.
Okay. So my connectivity is running, that's why. Okay. What are the synthesis of nanomaterials? In this synthesis, there are two approaches. One is top-down approach, and one is bottom-up approach. In this top-down, bulk materials are broken into nano-sized particles, that is powders. Okay. Example, ball milling and nanolithography. In this bottom-up approach, nanoparticles are made by building of atom by atom. Examples, chemical vapor deposition, CVD, and pulse laser deposition. Okay, in this ball milling, the bulk materials are broken into nano-sized powders. Okay, it's a grinder method. Okay. In this nanolithography, it's derived from Greek words, tiny writing on rocks. Okay. This includes various methods of modifying semiconductor chips at the atomic level for the purpose of fabricating integrated circuits. In this chemical vapor deposition, it is vaporized. The atoms are vaporized and deposited on the target. In the pulse laser deposition, the physical vapor deposition technique, where a high-power pulse laser beam is focused inside a vacuum chamber to strike a target of the material that is to be deposited. The material is vaporized from the target, which deposits it as a thin film on a substrate. These films are used in the nanotechnologies. This process can occur in ultra-high vacuum or in the presence of a background gas such as oxygen, which is commonly used when depositing oxides to fully oxidate. Okay, what are the changes from the bulk material to nanomaterial? The melting point decreases dramatically as the particle size gets below 5 nanometer. When the bulk material is broken into nanomaterial, then the melting point is decreased. At the same time, the band gap is increases. the main role of the play a main role in semiconductors. Okay, interatomic distance, that means the distance between two nearest center of the nearest neighboring distance is called interatomic distance. When the bulk material is reduced to nano, the interatomic distance also decreased. The surface volume ratio also increases. What are properties of nanomaterials? When the bulk material is broken into nanomaterial, what are the properties changed? The mechanical properties, in these mechanical properties, improved hardness and toughness of metals and alloys, ductility and superplasticity of ceramics. The hardness will be improved. In this electrical properties increase in ceramics and magnetic nanocomposites. In optical properties, increase in quantum efficiency of semiconductor crystals. In this magnetic properties, superparamagnetism is also achieved in this nanomaterial. The magnetic coercivity also increase. That means we can get hard magnetic material. Different dimensions of nano. 0 dimension, 1 dimension, 2 dimension, 3 dimensions are available. Okay, in this 3 dimension, all parameter of length, breadth, and height. In this 2D, only length and breadth, x and y axis will be available. In this 1 dimension, only x axis, only one parameter, either length, breadth, or height. In this 0 dimension is a single point. All are confined in a single point. These are the basics of nano. This quantum well is a 2-dimensional systems. The electron can move in 2 directions and restricted in 1 direction. Indium gallium nitride, multiple quantum well structure. Hello. What is it? So, headset மாத்தி பார்க்குறேன்.
சார்
Hello.
சார் அந்த எக்கோ மட்டும் அதிகமாக இருக்குது சார். நீங்கள் என்ன வேர்ட்ஸ் கிளியராக ஓகே
ரூம் ஃபுல்லாகவே கிளியர் பண்ணுங்க.
இல்லை சார் நீங்கள் என்ன சொல்கிறீங்க புரியல சார்.
Hello.
இல்லை சார் சீரியஸ்
Sir, actually you are not audible, sir. We cannot hear any single word.
There is no problem, sir. I usually use the headphone. I'm going to change the headset.
Sir, if you are having microphone in your system, kindly remove your headset and you can speak.
Okay, sir. Okay. Hello. இப்போ பாருங்க. Is it audible?
No, sir, not clearly audible.
இல்லைங்க சார், நேற்று இதே மாதிரி வீடியோ பண்ணேன். ஒரு நிமிஷம். ஒரு நிமிஷம் இருங்க, அது நாய்ஸ் வரும், அதான் பார்த்தேன். சரி, செக் பண்ணி பாருங்க வந்து. ஹலோ ஹலோ
Hello, sir. Hello, sir.
ஓகே.
No, sir. Hello, sir.
ஹலோ
No, sir. That. Sir, அப்படிதான் இருக்கு. சேஃபா தான் இருக்கு. சார் வேணா நீங்க சார் உங்ககிட்ட மொபைல் இருக்கு சார், ஸ்மார்ட் போன்ல
எஸ் எஸ் எஸ்
கனெக்ட் பண்ணலாமா சார்?
சார் 2 minutes சார். சார் just 2 minutes, just 2 minutes. சொல்லுங்க. ஓகே 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 ஓகே. இப்போ மொபைல லாகின் பண்ணணும் இல்லைங்களா? ஓகே 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 தேங்க்யூ ஜஸ்ட் 2 minutes.
Hello, sir. Huh?
Hello.
Hello, sir.
Is it audible?
Okay, wait, sir. கேக்குதா? Sir, hello, sir.
Hello. Is it audible, sir?
Yes, sir. Okay, sir. Yes, sir. Good, sir. சார் செஷன் ஃபர்ஸ்ட்ல இருந்து பண்றீங்களா எப்படி சார் மொதல் ஸ்லைட்ல
Okay,
இருந்து
okay, okay. Starting la பண்ணிக்கலாம். Is it audible? Is there any problem?
சூப்பர் இப்பதான் கிளியரா இருக்கு சார்
Okay,
எஸ்
okay.
சார் வெரி கிளியர் சார் கிறிஸ்டல்
Okay,
கிளியர்
okay, 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 okay.
தேங்க்யூ சார்
Okay, thank you. Thank you, dear. Good afternoon to one and all present here. I'm going to discuss about nanotechnology in satellite communication. First of all, what are nanomaterials? Already you know that it is in 10 power minus 9 meter scale. Okay, nanomaterials or the nanoscale materials are defined as a set of substances where at least one dimension is less than approximately 100 nanometers. A nanometer is 1 millionth of a millimeter, approximately 1 lakh times smaller than the diameter of a human hair. Nanotechnology, what is meant by nanotechnology? Nanotechnology uses the nanoscience. That means the synthesis and characterization study of nanomaterials and build up a new device which is used for our day-to-day purpose. Okay. Nanotechnology is a branch of engineering that deals with the design and manufacture of extremely small electronic circuits and mechanical devices built at the molecular level of matter. what are the interests? Why we choose this nano? Because nanostructured semiconductors have various non-linear optical properties. Nano-sized metallic powders used for the production of gas-tight materials, dense spots, and porous coatings. Nanostructured metal clusters and colloids of mono or plurimetallic composition have a special impact in catalytic applications. Nanopay ceramics are more ductile at elevated temperatures. Nanostructured metal oxide thin films are used in gas sensors due to enhanced sensitivity and selectivity. Polymer-based composites with a high content of inorganic particles leading to a high dielectric constant. These are the interests of nanomaterials. What are the synthesis method of nanomaterials? In this synthesis, there are two processes. One is top-down, one is bottom-up. In this top-down, the bulk material is broken into nano-sized particle. Example, ball milling and nanolithography. In this ball milling, the bulk material is broken by grinding process. We can get nano-sized powders. This nanolithography writing is derived from the Greek word that means writing on the stone. We can get minute circuit chips like that by using this nanolithography. In this bottom-up approach, nanoparticles are made by building up atom by atom. Example is chemical vapor deposition. In this chemical vapor deposition, the target are vaporized and the substrates are vaporized and deposited on the target. By using laser, we can get the nano particles. Okay, this is the ball milling. We use the grinding method to get the nano powders. Nanolithography, we can get the integrated circuits IC by using this nanolithography. By using chemical vapor deposition, we can get the nano material. It's a high quality, high performance solid materials can be achieved by using this chemical vapor deposition. Next one is pulse laser deposition. In this material, we can get nano materials. What are the changes when the bulk material is broken into nano material? When the bulk is broken into nano, the melting point will be decreases. Okay, the melting point will be decreases. Okay, at the same time, the band gap is increases. Then what about the interatomic distance? The interatomic distance is the distance between center of two nearest neighboring atoms. It is also decreases. Then total surface area, this is the number of surface atom increases with reducing size of the particle. When the size of the particle is reduced, at the time the interatomic distance decreases, the band gap increases, and melting point decreases. These are the changes happen in this nanomaterials. Okay, what are the changes in the properties when the bulk material is broken into nanomaterial? Okay, in mechanical, improved hardness and toughness of metals and alloys, ductility and superplasticity of ceramics. Okay, hardness will be improved. The steel high, it's very high hardness than the steel. The electrical properties, increased electrical conductivity. The electrical conductivity will be increased in ceramics and magnetic nano composites. In optical properties, increased quantum efficiency of semiconductor crystals. In magnetic properties, super paramagnetism will be achieved by using from this nano materials. Okay. Different dimensions of nano. There are 4 dimensions: 0 dimension, 1 dimension, 2 dimension, 3 dimension. In this 3 dimension, all parameter of length, breadth, and height. This material have a length, breadth, and height. That is 3-dimensional material. Okay. In this 2 dimension, they have only length and breadth. There is 2-dimensional material. In this 1-dimensional, only one parameter, either length or breadth or height. They have length, breadth, or height. In this zero dimension, these are confined at a single point, that is zero dimension. For example, this quantum well. Quantum well is a two-dimensional system. The electron can move in two directions and restricted in one direction. Indium gallium nitride and gallium nitride multiple quantum well structure prepared by metal organic vapor phase epitaxy, MOVPE, metal organic vapor phase epitaxy. This quantum wire is one-dimensional. The electron can move in one direction and restricted in two directions. In this quantum dot, it's a zero-dimensional system. The electron movement restricted in three-dimensional. Fundamental issues. What are the fundamental issues in nanomaterials? Ability to control the size of the system. We control the size. We want to give in nano size. So ability to control the size of the system. Ability to obtain the required composition within this nano size. We have to get the required composition. Ability to control the modulation dimensionality, that is 10 into 10 into 10. In this satellite communications called as 1U. Okay, 10 into 10 into 30, like that. The ability to control the modulation dimensionality. These are the fundamental issues. Okay, now we are going to discuss about satellite. In astronomical terms, satellite is a celestial body that orbits around a planet. That means the moon is a satellite of Earth. In aerospace terms, satellite is a space vehicle launched by humans and orbits around Earth or another celestial body. There are two explanations for satellites. One is astronomical terms, another is aerospace terms. Communication satellite. It's a microwave repeater in the sky that consists of transmitter, receiver, amplifier, regenerator, filter, onboard computer, multiplexer, demultiplexer, antenna, waveguide, etc. A satellite radio repeater is called as transponder. This is usually a combination of transmitter and receiver. Okay, what are the functions of satellite? Here there are two transmitting stations. Station 1 is used in send the signal to satellite, that is uplink frequency. Then the satellite send the signal to the another station, that is receiving station, by using downlink frequency. A satellite stays in orbit because the gravitational pull of the Earth is balanced by the centripetal force of the revolving satellite. Here the signal is transmitted from one station to another station by using the satellite. From first station to satellite is uplink frequency, then the satellite to second station is downlink frequency by using downlink frequency. Then what are the main parts of the satellite? Here the solar panel is used to function this one, then the antenna, rocket motor, batteries, fuel tanks, onboard processors. These are the parts of the satellite. History of satellites. The world's first artificial satellite, Sputnik 1, was launched by Russia in 1957. The first active satellite, Telsat, was launched in 1962. India launched the first satellite, Aryabhata, in 19th April 1975. Then Jugnu is the first Indian nano satellite. Was launched by ISRO with the help of IIT Kanpur in 2011. Okay, what are the difference between these conventional satellites and nano satellites? The conventional satellites have large in size, high cost, the weight above 500 kilograms, the developing and launching times more, is complicated to manufacture. When we come to nano satellite, they have much more compact, very cheap, weight less than 10 kilograms. Its developing and launching time is very less, simple to manufacture. These are the difference between conventional and nano satellites. Importance of small satellites. The small satellites reduce cost and time. The production cost and the launching time is really low. Cheaper launch opportunities, that is multiples or piggyback excess capacity. Cheaper designs, so we can produce huge level. Okay. Basic components of small satellites: the GPS receiver, sun sensor, magnetic rate sensor, battery, UHF antenna, S-band antenna, like that. Okay, thruster, GPS antenna. These are the basic components of small satellite. Okay, types of satellites. What are the types? They have mini satellite, that is small satellite, micro satellite, nano satellite, pico satellite, femto satellite. Okay, based on its mass. The small satellite having the mass 100 to 500 kilogram, its development and launching cost is $35 million. Time is 2 years. Development year is 2 years. We can switch over to micro. Its mass is 10 to 100 kilogram. The cost is $15 million, and the development and launching time is 1 to 2 years. When the size is reduced, the time and cost also reduced. In this nano satellite, nanosat, 1 to 10 kilogram, the cost is $5 million. Then 1 year is launching and development year time. In this pico satellite, its mass is 0.1 to 1 kilogram. Then the cost is $100 kilo. Okay, $100K. Then the time is 1 year. In this femto, the mass is 10 to 100 gram. It's in gram. The remainings are in kilogram. In this femto, 10 to 100 gram. Then $50K. Then within 6 months, we can develop and launch the femto satellite. These are the types of satellites. In this nano satellite, the weight is nearly 1 kilogram. Size is 10 centimeter. 10 is very, very small. This power, 1 watt. This memory is 1 gigabyte. Telemetry, 10 kilohertz. Sensors, 3-axis magnetometer. Demands of satellite nanotechnology. Demands of satellite technology. First one is cost reduction. The miniaturization of complete satellites is suitable only for special tasks. The reduction of weight and volume as well as energy savings can generally be regarded as a priority objective for cost reduction. What are the demands? The first thing is cost reduction. We want to reduce the cost of the satellite. Next one, lowering of mission risks. The cost of payload development for space missions and of the space transportation are usually very high, so that a reduced mission risk is given a high priority. An important objective is an increased reliability and durability of space components and systems. Increased capabilities, improved communication performance, improved communication performance, the availability of space qualified micro optoelectronic components, that is lasers, amplifiers and modulators, has to be improved significantly. Then innovative components and materials, innovative methods for 3-dimensional integration of electronic components in compact modules, wide backup semiconductor components, then evaluation of MEMS for satellite applications. Nano in satellite, materials for satellite. What are the materials used for satellite launching? Nanoparticle and reinforced polymers. The mechanical properties of polymers can be improved by dispersion of nanoparticles into the polymer matrix. Due to high mechanical firmness and resistance against heat and radiation, nanoparticle reinforced polymers have application potentials for various components in satellite. Next one, nanotubes, carbon CNT, carbon nanotube. It's 50 times stronger than steel and outstanding thermal and electrical conductivity. So it is used in satellite communication. Due to their special properties, CNT possesses numerous applications in thermal control devices, sensor technology, and biomedicine. Nanowire. They can be made from a wide range of materials such as semiconductor, nanowires made of silicon, gallium nitride, and indium phosphide. What are applications of nanowire? In high density data storage, either as magnetic read heads or as pattern storage media. In electronic and optoelectronic nano devices for metallic interconnections of quantum devices and nano devices. Metal matrix composites. Reinforcement of metals with aluminum oxide or aluminum nitride, their thermomechanical properties can be improved. Such metal matrix composites possess high heat resistance, firmness, thermal conductivity, controllable thermal expansion, and low density. So it is highly potential in satellite applications. Nanostructure ceramics. The sintering temperatures and the consolidation time of ceramic materials can be reduced by applying nanopowders, which saves not only money but also allows new manufacturing techniques like co-processing of ceramics and metals. Next one is thermal protection and control. In this thermal protection, ceramic fiber composites can be used for reusable and high temperature components. Nanostructured heat insulating layers are suitable as thermal protection for combustion chambers in propulsion systems. Nanotechnology used in the areas of thermal protection and hot structures for future reusable satellite systems. Thermal control. Nanostructured diamond-like carbon layers can improve thermal control systems of nanosatellites, since they possess approximately 4 times a higher thermal conductivity than copper. Another approach for the thermal control for miniaturized satellites are MEMS-based micro-cooling loops. Energy generation and storage. The satellites use the solar energy for its function. Okay. Solar cells. The efficiency of energy conversion of solar energy into electric current can be increased significantly by application of nanomaterials. Anti-reflecting coating for solar cells and collectors can increase the light conversion efficiency. When we use this anti-reflecting coating, then the efficiency will be increased. At present, the most efficient solar cells for satellite applications are based on third and fifth column semiconductors. The semiconductors are classified into 2 categories based on its composition. One is elemental and one is compound. In this compound, the third column element and fifth column element combine to get the semiconductor. It is very useful in this satellite communication. Thermoelectrics. Thermoelectric converters produce electricity from solar energy through a 2-step thermoelectric process in which electromagnetic radiation is first converted into heat and then into electricity. Thermoelectric converters harness the whole spectrum of solar light and have high theoretical conversion efficiencies up to 70%. Advantages of thermoelectric converters in comparison to photovoltaic cells are an increased conversion efficiency as well as high radiation resistance. Fuel cells. Fuel cells represent an efficient method for chemical energy conversion and possess substantial application potential in satellite due to their clean operation and their compactness. Nanotechnology offers different possibilities to increase the conversion efficiencies of fuel cells within the ranges of catalysts, membranes, and hydrogen storages. Ultra capacitor. Ultra capacitor is a general term that describes a capacitor that contains nano components. Ultra capacitors are being researched heavily because of their high density interior, compact size, reliability, and high capacitance. We use nano components in this capacitor that is called as ultra capacitors. Okay. The decrease in size makes it increasingly possible to develop much smaller circuits and computers. Batteries. The capacity and reversibility of rechargeable lithium batteries depend strongly on the microstructure of the electrodes. Nanostructure materials offer improvements regarding power density and durability by control of charge diffusion and the oxidation state on a nanoscale level. The increasing miniaturization of electronic components requires flexible batteries integrable into circuits. Sensors. There are some gas sensor. In this gas sensor is a device that detects the presence of gases in an area, often as part of a safety system. Miniaturized electrochemical gas sensors with sensitive metal oxide coatings are energy saving and can be easily integrated into CMOS, complementary metal semiconductor circuits. Three different gas sensors are used for satellite applications: Schottky diodes, resistivity sensors, electrochemical sensors. In the Schottky diodes based on silicon carbide, resistive sensors based on polymer films, the electrochemical sensor is based on tin oxide. Sun sensors. It's the simplest and most common sensors for attitude determination is the sun sensor. Sensor measures the angle of incident light from the sun with respect to an inertial body frame. Advantages of sun sensors on the basis of nanoporous silicon are decreased reflection losses and improved quantum yields. Ultra thin functional layers. This optics and electronics. In optoelectronics, a multiplicity of new components like organic emitting diodes or semiconductor diode lasers are based on nanostructure layer systems. Sensors and actuators in microelectronic applications often require the integration of the sensor and actuator materials into the components by means of coating process such as PVD, that is physical vapor deposition, chemical vapor deposition, or solder techniques. Magnetoelectronics. Ultra thin layers are the base for the development of magnetoelectronic sensors and memory chips with high potential for satellite applications. Applications of magnetoelectronics are magnetic memories as replacements for conventional CMOS memory chips. The advantages of MROM are data remain preserved in case of power failure. A small energy consumption is a magnetoelectronics. Nano-optoelectronics. Quantum dot laser. The quantum dot laser is a semiconductor laser that uses quantum dots as the active laser medium in its light emitting region. QD, that is quantum dot laser, or a small energy consumption through low threshold current densities, a high modulation range for high speed applications, as well as an improved temperature stability. Due to their radiation hardness and the low energy consumption, quantum dot lasers are used in satellite applications. Photonic crystals. Photonic crystals exhibit a periodic refractive index and possess an analogy to semiconductors in electronics. Photonic crystals are an example of nano-optoelectronic components with application potential in optical data communication. Infrared sensors. The miniaturization and improvement of infrared sensors are based on the applications of 2, 1, and 0 dimensional nanostructure. 2-dimensional, that is quantum well, 1-dimensional is quantum wire, and 0-dimensional is quantum dot. Alternatives for CMOS electronics. What are the alternatives for this? Complementary metal oxide semiconductor. Molecular electronics. Molecular electronics is the study and applications of molecular building blocks for the fabrication of electronic components. Due to special electrical properties, molecular electronics used in nanoscale connecting wires and components of transistors. Spintronics. Nowadays, the research on spintronics is going on. Spintronics is the spin-based electronics. It deals with the spin-dependent properties of an electron instead of charge-dependent properties. Spintronics is the logical advancement of magnetoelectronics. It utilizes not only the charge but also the magnetic movement of the electron for data processing. Quantum computing. A quantum computer is a computer design which uses the principles of quantum physics to increase the computation power. The utilization of the electron and nuclear spin contribute to the development of quantum computers. The electron have the spin and also nuclear have the spin. These are the contribute the development of quantum computers. Quantum computers are different from binary digital electronic computers based on transistors, whereas common digital computing requires that the data are encoded into binary digits, each of which is always in one of the two definite states, 0 or 1. Quantum computation uses quantum bits which can be in superposition of states. Logics with tunneling components. Tunneling components, example, resonant diodes, resonant tunneling diodes, harness the extraordinarily fast quantum mechanical tunneling effect. This promises a clear speed increase in comparison to conventional elements. Resonant tunneling diode from third and fifth column semiconductors, that is compound semiconductors, are already used as high frequency oscillators in the terahertz range, optoelectronic switches, photodetectors, etc. In satellite, ultra fast and energy saving processors for digital electronics in the satellite communication systems. They are used in nanotechnological data storage. In the area of data storage, nanotechnology offers potentials for the production of miniaturized mass memories with extremely high storage density, as well as for the development of new non-volatile working memories for computer systems, which will compete in the future with conventional memory chips like DRAM. Nanostructures in microelectronics. MMIC, that is monolithic microwave integrated circuit structures, MAFET, that is microwave and analog front end technology, or ultra thin chip stacking, which will play an important role regarding the miniaturization of satellite subsystems and systems. These are alternative for CMOS. What are the advantages? The cost of satellite and its handling is low. When we develop the nano satellite, the cost of the satellite and its handling is low. Due to less weight, several small satellites can be launched with single vehicle. Small satellite allowing non-space-faring nations, corporations, educational institutions, and even individuals low-cost access to space. It can be used in various useful fields like weather measurement, coverage of area, etc. Suitable for both digital and analog transmission. These satellites are capable of handling very high bandwidth. These are the advantages of nano satellites. What are the disadvantages? We have a lot of advantages and also it will be disadvantages for this nano satellite. Single unit launching of small satellites into orbit is costly. Single unit launching is costly. The coverage is not much wide. Satellite bandwidth is gradually becoming used up. Due to less power, noise interference in satellite communication may occur. Very difficult to repair and maintain in the space. These are the disadvantages of nanosatellite. What are the applications of nanosatellites? These are used in telecommunication, telemedicine, teleeducation, mobile satellite services, radio networking, village resource center, satellite aided search and rescue, satellite navigation program, satellite news gathering and dissemination, standard time and frequency signal dissemination services, television, training and development communications channel. These are the applications of nanosatellite. Actually, nowadays, PICO and femto channels satellites are also going, research are going there. So when we reduce the size at the time, the efficiency also increasing. This is main thing in the launching, development and launching of nano and PICO and femto satellites. Okay. Thank you, Bo. Any doubts, queries?
Students have any doubt? So I think no doubts, sir.
Okay, Bo. Thank you. Thank you.
So thank you, Dr. N. Thangaraj. That is wonderful session for sharing your knowledge and concept, sir. Thank you very much, sir. It's wonderful session.
Thank you.
So can
Thank you.
we-
I thank the Wings of Aero team for giving me the wonderful opportunity to deliver about the nanotechnology in satellite communications to aware the students to get the to improve their knowledge on the satellite communications. Thank you. Thank you, sir.
So can we end the session, sir?
Okay, sir. Thank you.
Thank you very much.
Thank you.